guys, welcome back. Today we will be exploring an open source project by Microsoft for prompt compression, which is LLMLingua. So let's dive in. So large language models have demonstrated remarkable capabilities and have been applied across various fields. Advancement in these technologies such as like chain of thoughts, in-context learning and retrieval augmented generation have led to increasingly lengthy prompts for LLMs, sometimes exceeding tens of thousands of tokens. So longer prompts however can result in increased API response latency, and also it will exceed the context window limits, and also loss of contextual information, and then also expensive API bills, and also performance issues such as like lost in the middle. So inspired by the concept of LLM is a compressor, so this approach accelerates model inference, reduces the cost, and also improves the downstream performance while revealing the LLM context usage and also intelligent patterns. So this work achieves a 20 times compression ratio with a minimal performance loss for LLMLingua and a 70.1% performance improvement with 4 times compression for LongLLMLingua. So let me introduce you quickly to their work on GitHub and hands-on notebook and also a published article that you can explore further after watching this session. Ready? And the research paper titled LLMLingua Compressing Prompts for Accelerated Inference of Large Language Model. So the author introduces a technique called budget controller. So here. So which dynamically adjusts the prompt length based on the complexity of the task. So in practical terms, this means that instead of like sending full length prompts to the model, you can compress them and making the process more efficient and quicker. So this is particularly beneficial for like applications that need real-time responses or when dealing with large volume of data. So here is the GitHub repository for LLMLingua. So LLMLingua offers two main techniques, the standard LLMLingua and the recommended LongLLMLingua, which is question aware. So to use the LLMLingua, you can call the compress prompt function with custom parameters. So as you see here. So that will allows you to fine tune the compression according to your needs. So it's initialized with the prompt compressor class, so which lets you specify the model name, device map and configuration for both the Hugging Face model and OpenAI embeddings. So LLMLingua uses the compact well-trained language models like GPT-2 small and LLMS7B, so to identify and remove the non-essential tokens in prompts. So this approach which enables efficient inference with large language models, achieving up to like 20 times compression with minimum performance loss. And LongLLMLingua mitigates the lost in middle issue in LLM. So improving the long context information processing, it reduces the cost and also improves the efficiency with prompt compression, improving the RAG performance up to like 21.4% using only by 1/4 of the tokens. So have you ever encountered the token limits when asking ChatGPT to like summarize the lengthy text? Frustrated with ChatGPT forgetting previous instruction? Experienced high cost using GPT 3.5 or 4 API? While large language models like ChatGPT and GPT-4 excels in generalization and reasoning, they often face like challenges, prompt length limits, and then prompt-based pricing schemes. So LLMLingua offers an efficient solution to compress the prompts by up to like 20 times and enhancing the utility of LLMs. So it leads to like cost savings, which reduces both prompts and generation length. Second one is like extended context support, which will enhance the support for longer context, mitigates the lost in the middle issue, and also improves overall performance. And third one is like robustness. So no additional training needed for LLMs. And fourth one is knowledge retention. So maintaining the original prompt information like ICL and reasoning. And the last one is comprehensive like recovery. So GPT-4 like can recover all key information from compressed prompts. So let me quickly show you the demo how you can use this LLMLingua. So you can pip install LLMLingua. Once it's done, you can just import prompt compressor class from the LLMLingua, and then you can specify the model name, device map, and then model config and also open API config. Once it's done, I am just using the custom data set for to import the complex prompt. So I am here using the open source data set. So just let me go through the dataset so quickly. So if you see here, we have the question and answer paths. So we're gonna import this with our prompt with the question. For example, if you see, we have the instruction here, and then we have our questions, and we have a prompt with the prompt complex variable which holds the data set. Okay, so with this large context, we will be calling compressed prompts. Okay, and getting our compressed prompt as a result. Prompt created here was like really shorter than the one that we sent to this function complex prompt. So if you see, the original token was like 938 as compared to the compressed token, which is 206 tokens. In the screen you see like Hugging Face demo part, so you can try it from here with your context. Like you can give your instruction, you can give your context as we did in the collab. Okay, so you can give your question and then you can try to compress the prompts. If you see the result here, the token numbers of the original prompt was like 2428, and the token number of the compressed prompt was like 331, and the actual compression ratio is 7.3. Let me go through the other examples like where LLMLingua can be applied. So LLMLingua can be applied to a wide range of scenarios, particularly in chain of thoughts, long context, and then RAG. So it have been like tested on various tasks, including like in context learning, summarization, conversation, and multi-document question answering, single document question answering, and also in the code completion and synthetic tasks. So the result indicates that this approach can achieve like minimal performance loss or even improved performance up to like 20 times compression ratio. So they have like showcased the several cases from the common real world scenario to demonstrate the capabilities of LLMLingua. You can find the examples in their GitHub example notebooks as here. So that's it guys. Thanks for watching and see you all in our next session. Bye bye.